I just have a quick agenda up, so hopefully this will go for about 45 minutes to an hour, depending on how many questions there are, or if anyone wants to dive into any particular section of the presentation. So just for a quick agenda, we're just going to go through what we're actually trying to achieve with developing tools for code quality. What's the end goal? We're going to talk about some common tool sets available in other sort of development languages besides Message Broker and Sterling, such as the tools available in Java like CPD and whatnot. Then we're going to go through a quick demonstration of Sonar Cube, and then we're going to finish off with the automatic diagram and execution groups and test code coverage in the diagrams. So what is it we're actually trying to achieve? So there's probably a few different ways people present this, but what I like to think, or how I like to think about code quality, is we're talking about writing cheap code. And what do we mean by cheap? So there's a couple of criteria, I think. One is it's bug-free, as in it does what it's supposed to be able to do. It can be understood, it can be it performs well, and it can be changed. Okay, so what we mean by this, in case of this, is cheap code is code that's cheap to write, and cheap to maintain, and cheap to enhance. So I don't mean we go and find out the cheapest developers and we put them in the dodgiest offices. What I mean is we try to write the simplest possible code that does the job, that performs well, and is neat and uncluttered, and also can be tested. And we'll dive into testing and test coverage a little bit later. Okay, so when we say what can be tested, we're talking about test coverage. So we're talking about knowing with certainty that the code that we've written executes and performs its contractual job, which gives us A, confidence that we've done the right thing, and B, gives us the confidence to be able to refactor code or change code easily and quicker than if we didn't have good test code coverage. And this prevents us having to do massive regression testing of our code every time we make a change, which by having good test code coverage means we can release our code and test, develop, and release our code more systematically and in quicker cycles. So how do we get to good code? Now this link here is from, this link opens up and talks about 7 deadly sins from the Sonar Cube people, and it seems like a good good summary. So the 7 deadly sins are, and what the plugin tools like MB Precise are trying to do is look for bugs and potential bugs. So if you've got a bug, infinite loop, synchronized section calling another synchronized section, in this case message record with atomics, code that goes to endpoints that don't exist, code that loops that branching from wrong place in loops, things like that. These can cause infinite loops, they can cause performance degradation, they can cause incorrect results to come back. Coding standards breaches. This is where we say we might document our code a certain way, or we want to write our code a certain way to be understood, and then when we deviate from that standard, that makes it more difficult for that particular piece of code to be understood. And that particular piece of code needs to be probably more reread so people understand it, because it's different for the rest of the code. So standardizing the code as much as possible makes it a lot more easy to understand. It gives all the developers the same language that they're using to talk about the code. Duplications. So duplications, by duplicating, what we're doing is we're creating additional performance issues or potentially additional maintenance issues. So if we have a particular piece of code that, say, calculates the amount of tax to be paid, and if we've got 5 different places that tax calculator is used, or sorry, if that tax calculator is written in 5 different pieces of code, then when we want to change our tax rates, we've got 5 places where we could introduce a bug. We've got 5 places we need to regression test, and we've got 5 places we could now introduce a performance issue. Lack of unit testing. If we don't know something works by testing it or unit testing it, we can't be comfortable changing it. And what this tends to mean is the projects that have lower levels of unit testing generally generally change code less out of fear that they might be breaking something inadvertently, which will affect business functionality. So what that means is even if there's a piece of horrible code that no one can really understand, no one will be willing to change it without a business driver. So if there's a project that comes along and says, well, we need to make changes to this code because we need to enhance some other piece of functionality, then that code can change. But just to allow developers to rewrite bad code to make it more understandable and perform better and less buggy, they don't have the confidence to do that without an expensive regression exercise, which means that code doesn't change, which means whatever technical debt is in your code that's untested remains in your code and is untested. And going forward, that means technical debt can increase over time. Bad distribution of complexity, so having one particular routine that's really complex while a whole of routines that aren't, and so on and so forth. Is there any questions? Right, we'll just move on. So unit testing. So just a quick definition of unit testing. Now, while we've talked about why unit testing is important, and we'll have a quick mention of how message MB Precise and Sono help to improve the quality of unit testing. So there's something in unit testing called code coverage, and what that is that's in the corporate world. If you come from a Java background, that's essentially recording what tests have been run and what, as part of that recording, what paths through the code those tests have taken. So if you have a high test coverage, which means a lot of your code is affected or has been executed by tests and you're still getting the correct result, then it's easy to change. That's called high test coverage. If you've got low test coverage, then not as much of your code has been executed, not as much of your code has been tested, so you can see it's more difficult to change that code. And so providing unit testing coverage, test code coverage as part of SonarQube and as part of the MB Precise plugin, this allows teams to measure the amount of unit testing they've got and hopefully improve the amount of unit testing they're doing over time. So that means you can introduce rules like if something is new and it's not tested, then it's an issue or what we call a violation. Find bugs is a Java, comes from a Java space, and essentially it's just an automated way of statically analyzing code and looking for particular well-known coding issues. And so we've got synthetically similar sort of checks as find bugs. Checkstar is the Java tool, and we have equivalent synthetic checkstar rules, and that checkstar means just tells you how your code should be, how your code should be documented, line lengths, minimum, maximum number of functions and parameters and things like that. Variable naming standards, comment blocks, types of comments, required functions, detection. And we mentioned before that copy paste detection or copied code is bad. And so copy paste detection allows us to measure how much copied code we have, and hopefully allows us to remove duplicate code and improve our code base. Which comes to technical debt, which is essentially the whole point of the code quality exercise is we want to minimize our technical debt. And technical debt is a term coined by Martin Fowler, I believe. And technical debt talks about how much bad stuff in your system there is that prevents you from writing code as efficiently as you can. So if you've got a particularly nasty piece of code that no one really understands, then that's technical debt, because you can't make changes around that functionality easily because you've got this thing that is of poor quality, and it affects everything going forward. So minimizing your technical debt now means that features you want to build out later are actually cheaper to do and quicker to do and easier to test. Continuous integration is a strategy or a practice where all your code from all your developers gets combined together as often as possible. The test cases are run, it's compiled, it's built, it's deployed, and it's executed as often as possible, so that we don't get any differences between what different teams and different developers have actually understood as far as the requirements go. So what this prevents is, in long-running projects where one team's working on one component, another team is working on, say, component A, another team's working on component B, that A and B are supposed to have a contract that allows them to interact together, but the contract, and when it comes to actually putting the code together, it doesn't work and it's buggy. Continuous delivery is sort of a partner to continuous integration. Continuous delivery is where you intend your software to be in a deployable state as often as possible, or as from the majority of the time. So what that means is that when we write a particular piece of code, we want to have the code as correct as possible at the start, or once we've delivered it, so that when it's ready, so it's almost always ready to be deployed to the customer, or almost ready to be deployed for testing, so it can be given to the customer. So what that means is that we can deliver our features quicker and get our better business return. Snowflake setups. Now, Snowflakes are kind of unique configurations and unique setups. So in the case of this particular Martin Fowler discussion is talking about Snowflake servers, but in terms of message broker, we're talking about Snowflake deployments, where your deployment to production might be slightly different from your deployment to dev and slightly different to deployment to test. So you want to make them as standard as possible so that you don't get issues popping up in production that you never saw in development because there's slight differences in the configuration or slight differences in the code, or something's been done manually that was done manually in the lower environments but wasn't done as part of the production release instructions, and hence breaks. And this is just a developer works article talking about integrating Sonar in your environment. So it's a good read. So when you get a chance, I highly recommend you have a bit of a read through. Cool. Okay, so let's have a quick look at Sonar. This is the Sonar that tracks violations and metrics, and we'll get into those in a second, and your source code. The second is the GUI, or the web interface that we're seeing here, which allows you to see those. And the third interface is the actual operational interface, which is how you when you run your analysis, it talks to the database. And essentially, it's an interface you don't see, but it's good to know a little bit about it. So we mentioned metrics. So Sonar has a couple of key components that it's going to give you. One is metrics, one is violations, one is unit test coverage, and one is code duplication. So in this case here, we're talking about metrics, which is information about your code that may or may not provide, may or may not indicate an issue, or may or may not indicate performance problems. Or as a measurement, a pure measurement, it could be a measurement of complexity. So we've got a few here. We've got number of nodes, number of MQ input nodes, which by itself doesn't mean much, but if you don't use a lot of them, like one of our customers doesn't use a lot of them, they just want to know where they were. So these are just purely informational. RCD nodes, the number of RCD nodes in your code, because RCD nodes potentially can affect performance. The flow length, again, this is something that can affect performance, which is basically a measure of the complexity or potentially processing time for a particular flow. So if you've got a long flow length, which we'll just see here, it's measured in descending order or ascending order, we can see that this particular message flow here, which I'll just bring up Message Broker while while I'm here. This particular message flow here is the longest, has the longest number of nodes running together. So there's the longest running path. So that means, what that means is if this is the flow that executes lots, and 4 isn't a very long node path, but this is just for an example. If this is the flow that it's executed lots and has a long path, then it's potentially going to be it potentially could be improved as far as performance goes. Cyclometric complexity is a measure of how many particular paths through your SQL. So a cyclometric complexity of 1 means you've got one possible path, and it's ranked by complexity. So we'll look here. What we're looking at here is this is saying it's the most complex piece of code, and hence it's most likely to be something that's harder to understand here. So what we can see here is this piece of code has a path, a complexity of 1 because on the way in it has a branch which gives the complexity of 2, has another branch which gives a complexity of 3, or in this case 2, 3, 4, 5, because there's 5 different paths through. Then we've got a loop which gives another complexity, another additional if statement with an else statement, which increases its complexity. So we can see here, if you want to test this code, we can see there's quite a few paths through the code that would need to be tested. String manipulation load is looking at the amount of string manipulation functions in your SQL. Obviously, the more string manipulation you do, the more expensive in terms of CPU it could be. So it just gives you an idea of where you're mostly doing your string work, and whether or not it could be refactored, or whether or not it could be used, done alternatively, like with a Java regular expression, or offloaded to a Java process node. And the rest of these processes, operations, and complexity are related to Sterling, which we don't have a lot of in this demonstration. So that's violations. Sorry, metrics, which as it gives you, doesn't necessarily mean anything good or bad, just gives you broader understanding, or a better understanding of your code base. And gives you an idea where you might want to look for stability. The next component of Sonar is violations. So violations are what we call your would be your check style, your PMD, or your find bugs issues. So these are things where the analysis, the code is indicated where you've either deviated from a coding standard, or you've potentially got a performance issue, or potentially got a defect, or you're, for example, using a deprecated piece of code. So for example, here we're looking here, we've got the schema name. So what we're looking at here is schema name in the property file. So we'll look here. So go to the code. Oops. So we're saying that this schema of the message code, message flow, isn't actually mapping to the schema of the path that the file is actually within, which means it does make it could be confusing. This one here, what we're looking at this violation is we're saying that we're using a deprecated parser, so we're using in this case we want to be using XML and SC, and we're not. So it's a particular coding standard that one of our customers has. Same with parse timing. So these are standards that the particular customers have requested, so they end up as violation rules. I'll just go through and find something a bit more generic. Okay, so node here, node refers to an empty main method. So essentially we've got what this is saying here is we've got a compute node within a message flow, but the compute node doesn't actually have any code in it. which means the compute node essentially is benign. It doesn't do anything, but because you're creating a compute node that does nothing, it's potentially either you've gotten the right code or it's a performance issue. So yeah, so on and so forth. So what we can do is we can have a quick look in. We'll just log on into the console here, and we'll find. And we'll go through looking at the available rules, and then we'll drill into some rather than just randomly jumping around. Okay. So for example, here we've got a style sheet. In the style sheet, we've got so in here we've got a style sheet, and within the style sheet we've got a variable that was never used. So for example, so we're looking here. DBRS2 is defined as an unused variable in the style sheet, which means that it's allocated but never used, which means that it's slowing our style sheet down, and can either mean be saying we've got a coding defect here. So what we're saying here is we've just declared a variable with one name, but we're actually using a variable with a slightly different name. So this is actually a potential bug. It's either a potential bug or a performance issue. And if it is just a performance issue, even though that would seem like a benign issue, it is adding extra clutter to the code, which the developer will then read and will try to work out what this variable does, and then work out that the variable actually doesn't do anything because it's never used. So it's time that developers wasted understanding the code. So if we go back here to rules, and we'll find a couple more, just to give you a bit more of an idea of the sort of checks that the tool does. Okay, so we've got here if missing else. So we'll look here. Okay, that's a bad example. Let's go back to issues, because that's a particular about to do with mappings. Okay, so we've got here. Now what we've got here is a main method referenced by more than one piece of code. So we've got what we're saying here is we've got. So what we're saying here is we've got the same node, we've got the same compute node ESQL code being used by more than one compute node. So what this means is that if you've got a particular bit of logic you're writing and you make changes to that logic, this actually will change it in multiple. It will actually change the logic in multiple places, multiple flows, which may or may not be what you want. So inadvertently, you could introduce a bug in one flow by fixing changes or making changes to another flow. So what this is slightly, it's a reuse scenario, but it's a little bit different to say writing a function, which has a particular API and does a particular piece of logic. So in this case, if it's something that is a piece of code that potentially should be reused, it might be better off being written as a common function or common procedure. That way, you won't inadvertently introduce bugs into other pieces of code. Missing out terminal. Okay, that's a monitoring event. So we'll hopefully get an idea of the sorts of checks that the that the violations do. Now, there's a lot to go through, especially when you take into account the style sheets and mappings and data power as well, and Sterling. Does anyone have any questions before I move on to duplication and test code coverage? So the next one is code duplications. Now, code duplications can produce some false negatives just because of the nature of the way ESQL code works. Where sections of ESQL code will be automatically duplicated because of the way the tool generates ESQL code with copies of copy message headers and whatnot. So what we're saying here in this particular case, and this is a bit of a contrived example, but we'll open it up. Waiting for it to load. What it's saying here, this particular piece of code is actually duplicated in another file. So we're talking about here, we're talking the flow1 compute node in single is actually duplicated by the entire piece of code in coverage1 flow1 compute node. Now the reason for that is because we've duplicated the code for the sake of the presentation. But if this was something you would see in production code, you would definitely be looking into why large chunks of code have actually duplicated, or functions have been duplicated, rather than being written as common functions. We'll have a look at this one here. So we've got reply handlers. In this case here, so there's a bit of a false positive because we've got copy message headers, which generally will be copied. Although it just does highlight here, we've got here this what we call this empty made method. So essentially, it's a node, a compute node that has no processing function, has no reason to be there. And this one here, we're talking about a coding standard where you should have a method. Should have a comment for all your methods or your modules, say what the module should be doing. This one here is saying it should be a header in all the files. The header should contain information about who it belongs to, and it should contain also header, or it should be in a non-default schema. So we can see here there's some issues with this code, and we've got a method which is an unused method. So essentially, this piece of code can be deleted. So that's coverage. Oops. So we'll just go back into So that's code coverage. Code duplication. Next, we're going to look at test code coverage, or unit test coverage. Now, test code coverage is set up using something called the what's called the generic coverage plugin. And essentially, what you do is you include the plugin, and then in your project you tell it where you want to pick up your coverage reports from, and the coverage reports in a particular format. The coverage reports get generated on the back of some Ant tasks and some instrumentation we do. So what we have is a process that takes your deployed bar file, and I can probably just quickly show you here. That takes you build your bar file. In this case here, we're just doing a build bar. And the trick here is to deploy a source, because we need the source to be able to instrument them. So we take the source. So we deploy a source. What we then do is what we say is we instrument the file. So essentially, this is it takes a parameter, which is the path, and gives it gives the bar file name you're instrumented, and gives you a path to where you're going to produce your empty coverage file. So what we do is when we instrument the bar file, we work out all the places that could be tested or could be executed, all the paths that could be executed. So we record what flows are there. We record within the SQL, or where in the SQL there's an if branch, or a while loop, or a function. What we then do is we we start something called the recorder. I think it's called the recorder. We start the. I'm just going to try and find it here. Sorry. We start the listener, what we call the listener. Essentially, this sits in the background and just waits for Message Broker to tell it which pieces of code have been executed. Now, generally, you just deploy this on the same place your brokers deploy, the same place that your broker's running. So you have your broker running in the same place as your Jenkins job, or where you're running your build script from, but it doesn't have to be. So there's no reason your broker couldn't be calling back across your network to another box if need be, if you're doing it remotely. So that starts the recording process. We then run our tests. In this case here, we've just got some URLs. We just hit the URLs, which do some work. And then after that, we finish up with what we call the stopper. Essentially, at the end of it, it writes the file that contains our coverage. In this case here, this is an example of the coverage being run. And we can see here that we've got some flows to say whether the flow was run or not. And then with the new ESQL, we've got some paths to the SQL, and we've said whether or not that particular path has been executed. So what that ends up looking like is in our Sonar, that coverage gets recorded against the files we're looking at, and we end up with this coverage report. So what we see here in this particular case here, we've got a whole bunch of files. Oops, let's go back here. So we've got our files and we've got our coverage. And these are the files here that we've said we've recorded coverage for. So basically, if it's not shown up here, that hasn't been tested. Okay, what we can say here is we deployed this piece of code, and we can see here it's not covered. This piece of code was never called. It's an empty node with an execution within a flow that just doesn't look to do anything, and it was never called. This one here you could see indicate that it may not be called because it's with an error handler, but this flow here again is another node, doesn't do a lot. So we see here we've got a violation, and we've got a violation that says it's still an empty node because even though there's code in here, these two methods don't do anything. So still, we could remove this node quite happily. We wouldn't be losing any functionality. But the interesting thing here for test coverage is we're looking here and it says we've got this particular piece of code isn't tested, and of course these ones aren't tested here because they were never executed. This particular, this one here is a flow, and what we're saying is this flow itself has never been called. And then we've got this flow here. There is ESQL here, and this ESQL has been tested. So what we can see here is we're saying, well, this particular piece of ESQL has been tested completely, or has been this line, or this function has been started within the function. We've got an if condition which is partially covered. This particular branch, the if condition has never been tested. This particular else path has been entered. This particular, within this else path, this particular if condition was never tested. This particular if test was executed. This particular branch, the if test wasn't. This particular branch, this if test was. So what we can see here is we can see that this is the path we run through the code. So what we're ideally looking for in our test coverage is you want to see that all our major pieces of functionality have been called. So in this case here, we're looking at a complicated function has been called, and this particular complicated function, none of these conditions here have been executed. Okay, so that's, does anyone have any questions? If no one has any questions, we'll move ahead, and we might finish a bit early today. So So that's coverage, that's duplication, that's metrics and violations. So the next on the agenda is we're talking about diagram generation. Well, actually, before I do that, there are some rules here which we'll see relating to. We'll see here relating to columns not being referenced, a column being referenced has not been indexed. So what we have here is it's a hybrid violation based around what we're broken, what we're doing at runtime. So what we're trying to do is we take the code we see in the database accessing code we see in Message Broker, and we try to match it against what we know about our database connections and what we know about our tables and columns. So what we're trying to do here is we're trying to match our ESQL SQL up with what our tables are expecting, or what our tables look like. So what this means is we can do things like checking that there may be a piece of code that hasn't been completely tested yet, but it may be referring to a column that doesn't exist. And so that would be a runtime error you'd pick up whenever you ran that piece of code. And if you're not doing a lot of regression testing, then that may be something that doesn't pick it up until you hit production. We've got some other things here, like a column being referenced has not been indexed. This may affect performance. So we'll just see if there's any issues here. That's what we're saying here. So we're saying here we've got a piece of code that looks to be going off to the database. And what we're doing is we're connecting up to the database, and we're running a select on a particular field where a particular value is so we're saying here, this particular field we're doing a select on, but there's no index. So this particular query might run perfectly fine in development, but when we actually hit production, where there may potentially be multitude more records, then it may start not performing. That's something you may not see in your initial developer and developer testing. So what we're trying to do is shortcut that error processing cycle by trying to identify these potential issues at the code analysis level. So with that in mind, and that database checking, which is configured as part of your properties, where you tell where we tell the plugin where the database is and what user is to test. So ideally you point this at a non-production database, but a production-like database, so you can extract the table definitions. So with that in mind, we end up with getting to what we're talking about, diagram generation. So because we're doing a lot of unpacking of message flow code and some flows in ESQL files and MQ files, MQ configuration files and map files and style sheets, we're building any memory graph of a lot of information about our project. And what that led to is creating something called the Automake diagram generation tool, which basically looks at all your code as an entirety and tries to give you a bit more of an intelligent top-down view of what your code looks like. So, and this gets generated out using this Sonar diagram output path, and it's just some standard HTML pages with a bit of dynamic runnable SVG, or some SVG that gives you a bit of interactive SVG. Sorry. So what we'll see here first off is we've got some boxes. Now this probably doesn't mean a lot because there's not a real it's not a real project I'm looking at here. It's just a cut down version of the project. But if we just show you what it might look at what we look like on a real piece of code. It might look more like this, which is not so useful for our demonstration, but it shows that there is a lot of we can see here there is a lot to this particular piece of flow, and this shows a lot more realistic interactions. But for the purpose of our demonstration, we'll stick with this one. So what we're saying here is we've got it's telling us that we've got a flow that interacts with the queue. The queue is called MQ test1 and interacts as the input to test MQ A flow. So what we're saying is when we put a message in MQ test1, it ends up at test5 MQ8 message flow. There's a little bit of information here. So we've got the flow description, which is pulled from the message flow itself. Tells you a little bit about the message flow. In this case, tells us nothing because it hasn't been documented. We've got the ability here to export the same thing as a JPEG file, just for printing and documentation. And what this is saying is this particular flow interacts via a queue. We're looking at test 3, and we're seeing that test 3 actually responds to an incoming SOAP or incoming HTTP request. Again, no documentation, naughty. So this incoming SOAP or HTTP request, test 3 will trigger this particular message flow. So if you need to understand as a new developer, or if you've got a fairly complicated business process, you need to know what particular interactions happen and how things get triggered, you can look at this diagram. I'll give you a bit more of an idea of the workflow. And in a real diagram, we can see here these lines. These lines indicate that there's an interaction between these flow, but based on queues. So what we're saying here in this particular one is this particular message flow writes to 3 different queues, and this particular queue is picked up by another message flow. So it looks through the queue to see where the consumer is. So we can see here that there's an interaction between this particular flow and this particular message flow here. These two here, and you can start seeing, having an understanding of how the business process works, rather than just looking at a single flow. The S indicates that it's consumes or as SOAP as an input. As in the diagram we haven't seen yet, there's an F, and the F indicates that it's a file-based. And for some reason the SOAP node hasn't shown up on that. So I need to look into that. So that's the diagram. So it's fairly simplistic, but if you imagine that a real interaction more like this, you would see a lot more. In this case here, we're looking at a particular flow. Now we've got a message flow here with no inputs or outputs. That could be unusual. That might be what you're expecting, but it doesn't sound very logical to me. So in this case here, we might be looking at something that's actually redundant code that potentially could be deleted because it can't be triggered, as in far as we can tell. So that's the flow interactions. I said we're talking about those flow documentation. So what we have here is we have got a summary of the flows, and we can see here we've got 7 flows in the system, and these are the documentation against the flow. So I'm going to open up the flow. In this particular case, this flow, oops, the documentation up. This particular flow has some documentation which tells you a little bit about it. A flow that returns a message. That's useful, but at least we've got some documentation. So if you give this to a business support person or some sort of operational support person, they might be able to diagnose where business processes are failing, or help diagnose where business processes are failing because they know where messages should be going to. So what we can see here, we've got a bit of a summary of the flows. And this here, we've also got a bit of a summary of the queues. In this case here, we've got 2 queues defined in our system. And we can see here this particular queue interacts with this flow. We can see the flow. We can see there's no alias for it. We can see that it's part of the message breaker processing. We can see that's not being either written or consumed by data power. As far as we can tell, it's not written or consumed by Sterling Integrator. Obviously, a more complex example. There'll be more flows, more queues, and we might actually see some of this is yes. And you can sort here by Now we talked about pulling apart the SQL to work out what potentially performance issues it might be, or any potential defects if they don't match the schema in the real database. What we've got here is another view of the SQL. What we've done is we try to pull apart the SQL that we do find in the code and display it here for our developers and DBAs. So So what we've got here is the original SQL that we found within the code, which goes and gets some information from events, and then what we then do is then we repackages what the database or DBA would actually see if that piece of SQL is actually running. And so this is what we can give this particular view of our world to our DBAs, and our DBAs can look at what the SQL that the broker is doing to their beloved databases to see if there's something that they need to be aware of, or whether or not there might be some performance issues we're not aware of yet, because we don't run this particular code yet, or we don't run it in a real environment. Data source, a bit of summary of data sources, properties, all common SQL message. So we've got what we've done is we've extracted some common code, or what looks like common code, and so what we're trying to do is automatically build up a library of common functionality. So in this case here, we'll pull out some common code, which doesn't look to be all that common. So it looks like these are all from a database flow. But the intention with this is if you throw it as a more realistic version of the code, you'll end up with a bit of a library of common functions. All Java methods, so everything, all the places that we call out to Java from SQL, all the stored procedures we call out to, events that are used for monitoring, all the files that are basically read, all the files that are written, all the incoming URLs. So we can see here we've got 1, 2, 3, 4, 5 flows, and they respond to different URLs. In this case here we've got slightly confusing architecture. We've got 2 flows responding to the same query. Same querying URL, which sounds like could potentially be an issue. We've got output URLs. So these are all the external to the broker resources that we're using. So it could be external to the flow resource we're using. So this could be going out to another external system, or going to another broker, or another internal system. Throwing exceptions is just a little bit of a summary of all the exceptions, and just gives you a little bit of a look to see if you can standardize those messages. Data power input URLs, data power output URLs, processes and locks are Sterling specific summary information. So this gives a bit of an idea of, or a bit of a summary of all the different components of our system, with the intention that it helps us to see if there's any additional sort of quirks in our system we need to address from an architectural point of view, or a bit more information for support people, or a bit more information for new developers, or a bit more of gives architects a bit more of an idea of what standards are developing, or what standards should be there. So that's the diagram generation from a documentation and workflow point of view. The last 2 things I'd like to demonstrate in the diagram are flows tested. So we talked about execution test coverage. So what we see here is we've got red and green. Hopefully it's fairly understandable that green means that this particular flow is being tested, and we've got 4, 5, 6 other flows that haven't been executed as part of the test coverage. So ideally, if we're doing our unit testing and our automatic or our integration testing with some sort of automatic tool, we'd like to see all these boxes as green to indicate that they've been executed. Oops. So I'll just turn those off. So there, green shows that the flow's been executed. Now the last one is the summary of the execution groups. So what we do for this is, much like the runtime information, we have a generated, or we have a automatically a little Java process that ties into Ant and Maven that connects it to broker and extracts a formatted file called a runtime XML file. And then inside this runtime XML file, it tells you what execution groups are there and what flows are in each execution group. With the intention this helps operational type people understand how parts of the system work, how different flows are deployed, and also helps to enforce standards around your security or any other sort of design you have about how the code should be running once it's actually deployed somewhere. So in this case here, we can see that we've got a whole we've got a color per execution group. So if we pick, for example, we see here, we won't pick this one, but this one here, we've got one execution group with nothing in it, which is sort of might be potentially an issue, or it could just be something to do with the way operation works. So operations work. So essentially, we've got here a flow with nothing in it. We look here. We've got these two flows. And again, imagine that the diagram was more like this one here. Well, so these two particular flows are in the same execution group. So it looks like we've got two SOAP flows in the same execution group with one that writes to a queue. Turn that off. We've got one here. This particular SOAP flow is its own execution group. This particular execution group has two flows. This particular execution has got three flows, but only two of them look to be coming from our source code. So it looks like we've got three flows in one execution group, but we don't have matching source code for it. So this could be because they've deployed some other way. They're from some other part of our system that isn't part of this source code analysis, or it could be that's a rogue or phantom flow that potentially shouldn't be there anymore because we've actually deleted it, but for some reason it's still running somewhere. And again, the last one here. So a couple of flows there. Again, only one of those flows in our source code. The other thing about this is aiming to help us with is decide on rules for how we might look at availability. So, for example, here we've got this particular execution group can have two different flows. This particular flow is deployed in two execution groups. So this helps us decide. Sorry about that. Just a bit of an issue. And so what we might look at a combination of this particular execution group information and our source code, and we might say that we want all our execution groups, all our MQ flows to be deployed to at least two execution groups to aid in stability, and also add to allow for failover in case one execution group's hang. And what we can see here is that we've got some of these flows with queues in them only in one execution group. So again, this gives us a bit of information about a bit of feedback of how things are deployed. Going forward, the next piece of functionality or feature we are looking to include is something called the rules configuration. And so what we're planning to do is set up a template or generate a template that architects and developers can fill in about the particular execution groups and particular broker rules that can be combined with our source code and our runtime information to produce meaningful violations around whether or not things should be deployed in the way they are. So, for example, if, as I said, if we decide there's a rule that all MQ message flows should be deployed to at least two independent execution groups, then we can look to enforce a rule that will be reported back in our Sonar console when we find the particular flow is not deployed in one, or is only deployed in one, or isn't deployed in more than two. So if we have a flow deployed in three execution groups, we might flag that as an issue because it could affect the performance of other flows in the same execution group. We might have a rule that says all SOAP, incoming and outgoing SOAP nodes should only be in one particular, or all file base knows should only be one execution group because that's when we've dictated that we want to have heightened security privileges. So what that means is you have reading and writing to the file system from a different execution group. That could indicate that someone has deployed something where they shouldn't have, and you might be, as they're giving a flow with an execution group extra heightened permissions when we don't want to be doing that. So we just come to the end of the presentation. Hopefully everyone got something out of it. If you do have any questions, feel free to reach out to me via our contact site, which will email us, or alternatively we have actually added online chat support now. So if you're online, please feel free to say hello or ask any questions you might have. Otherwise, feel free to email me at richard@bettercodingtools.com to find out more. Please enjoy the rest of your evening or the rest of your afternoon, depending on where you are. And I hope you enjoyed our presentation and got some food for thought at least. Thank you for joining us.